It is my absolute pleasure and delight, an honor to introduce Dr. Stephen Katona, who I am embarrassed to admit, and I hope I don't embarrass him, was somewhat of a hero to me when I was growing up. He's one of those people you just wanted to be, you know. Of course, then he had a huge bushy beard, and I was totally incapable of growing a huge bushy beard. So it was quite a surprise back in the late 90s when I got a call from Dr. Stephen Katona asking if I would like to come work at College of the Atlantic, and I was very honored. Steve is an icon in the marine mammal world. He was the founding member of Allied Whale, and he was also a very important early faculty member at College of the Atlantic. Around about the mid-90s, he chose to move away a little bit from Allied Whale and became president of the college for many, many very successful years. And he moved on from the college about 4 years ago, I guess, and has, after taking a well-deserved break, has ended up as now the managing director of the Ocean Health Index project for Conservation International. And he's also an adjunct at New England Aquarium. Steve has done many, many things with marine mammals. You know, he was one of the guiding lights behind the whole principle of photo identification of humpback whales. Allied Whale, which really put Allied Whale on the professional map. He has been the driving force for Allied Whale to keep this god-awful, lonely island 25 miles offshore called Mount Desert Rock, where many, many of our very important research projects have been happening. And we've always looked to Steve, even though he's not with us here at the college anymore, as kind of a mentor and a figurehead. So I'm absolutely delighted to introduce him here today, and he's going to be talking about links between ocean health and strandings. Thanks very much. Steve.
Hi, everybody, and thanks, Sean. It's great to be here. I want to begin with a disclaimer. It's been a number of years since I was directly involved in research on marine mammals, and I haven't been to a stranding response since sometime in the 1990s. It's probably 20 years, and that's a long time. It's probably not a sufficiently long time for new species to evolve, but it's long enough for 3 new cetacean species to have been described. That's Perrin's beaked whale and the narrow-ridged finless porpoise and Omura's whale. Imagine that, a whole new balanopterid. And also in that time, 8 new subspecies have been described. You're not going to see any of these unless you join a stranding team elsewhere, but that's the Kerguelen's island commerson's dolphin, the Maui dolphin, the Guyana dolphin, the Indo-Pacific common dolphin, the dwarf spinner dolphin, Australian snub-nosed dolphin, that's a very interesting one, split off from the Irrawaddy dolphin, and Black Sea species, subspecies of both the common dolphin and the harbor porpoise. No, I'm sorry, the bottlenose dolphin. And also a new species, relicta, a new subspecies of the harbor porpoise. So all of those have been described just in the short time since I went on my last stranding response. So you'll forgive me, I think, for viewing the stranding field today from some distance and some altitude, and any errors that I make, I hope you'll forgive. So I don't want to go any further without congratulating many of you for your recent recognition by Popular Science for having one of the 10 worst jobs in science. It's a great honor, and most of you have probably memorized the citation, which reads, oh, that's nice. You have to get rid of that. It's probably a stranding. The citation reads, whale slasher, Michelle Berman of Santa Barbara Museum of Natural History and crew cut open the carcasses of whales and dolphins that wash up on shore to study what is killing them. Researchers often have to stand knee-deep in blood and slice through fatty whale oils, which can stick to hair and skin for years. Well, of course it isn't as bad as all that. The fatty oils don't stick to hair and skin for years, but only for a few weeks, maybe a month, after which your partner is generally willing to sleep with you again. I'm sure that Michelle accepted that award on behalf of everyone who performs similar work, including those who toil amongst rotten seals and turtles and birds, many of which can go stench for stench with whales and dolphins. But one thing isn't clear from the Popular Science article, and I've studied it. What's not clear is how the 10 worst jobs were ranked. If they were listed from better to worse, then those of you with a Buddhist bent will want to do your jobs well and live lives of merit so that in future incarnations you will steadily work your way up the ladder with refreshing pauses as bean counter, bad dance observer, corpse tissue reaper, oceanic snot diver, doomsday fact checker, sneeze modeler, fecal transplanter, that is an interesting one, and the ultimate goal, armpit detective. If, on the other hand, they were listed from worse to better, you've already performed admirably in those stations during your past lives, but the article contains no guidance on your next trip. It's worth noting parenthetically, and this is my personal observation, that science, well, nature anyway, is also headed toward a nadir. And I'm not talking about environmental decline either, but rather the recent announcement that the Discovery Channel has apparently engaged Sarah Palin to host a nature series, Sarah Palin's Alaska, adding salt to the wound by reportedly paying her $1.2 million per episode. Now, if that's true, she'll learn in an hour or two more than any of us in the room in our lives. And she won't even have to carve up nasty corpses. On the other hand, she's doing her best to keep us in corpses for years to come through her continued trumpeting of drill, baby, drill, even in the face of the unfolding catastrophe in the Gulf of Mexico. So today, I want to ask a few obvious questions. Why do we like this nasty work? Why do we do it? What good is it? And what is its future? It seems to me that people have always been interested in strandings, but for different reasons that evolved during a succession of different ages. I think first came the age of utility. That's a very long period that may encompass much of human evolutionary time, during which many of our ancestors that lived near the coast made good use of stranded animals for food or products. They would have happily welcomed a dead whale for meat or oil, bone for tools or structures, baleen or teeth. Any seals or walruses would have been used for meat, skin, sinew for binding and sewing, bones again and teeth. Turtles would have been used for meat or shell, birds for meat, feathers, and also bones for tool making. This period surely started before people had the ability to capture these animals themselves, and it's never really ended. Native hunters and gatherers in surviving cultures still use strandings in these ways when they can. The age of utility still creeps along in Inuit cultures, and I suspect even here in our very midst. I know for a fact that it was alive and well back in my day, as we were always looking to salvage an edible souvenir for the grill. And there were some who accumulated fairly lengthy and exotic lists of barbecued items, lists that the rest of us admired. Why we admired them was really never quite clear, since pretty much everything we tried tasted like liver marinated in rotten fish. The only possible exception being one suckling fin whale that we had the good luck to necropsy. What's more, we were blissfully ignorant that we might also be consuming some interesting parasites, let alone pathogens like Brucella, Erysipelatrex, Leptospira mycobacterium, Mycoplasma, and a few viruses and fungi thrown in. But what did we know? Well, much later came what we might call the age of curiosity. Expansion of the British and French empires, though primarily for economic purposes, stirred a frenzied interest in natural history. The steady flow of unusual specimens brought back by expeditions stimulated enormous interest in obtaining, describing, and displaying anything that could be collected and transported. The motivation for collecting was no longer utility, but instead novelty, not only for scientific purposes, but perhaps also to gain insight into God's grand plan for creation. And among the specimens retrieved were marine strandings, including the type specimens of quite a number of marine mammals that would otherwise remain unknown, such as a number of beaked whales. Now, this period hasn't ended either, as some of the beaked whales demonstrate. Mesoplodon bodeni, which is thought to have evolved at least 40 million years ago, is known from only 35 circumpolar strandings, mostly from New Zealand and Australia, but also Tristan da Cunha, the Falklands, and Tierra del Fuego. No live sightings at all. It's all from stranding work. And the two most recently described mesoplodons, Perrin's beaked whale and Mesoplodon peruvianus, are sister species that diverged at least 5 million years ago, telling no one of their evolutionary plans. And as usual, it was beach scavengers and stranding responders who spoiled their little secret. Mesoplodon perrini is known from 5 stranded specimens found along the California coast between 1975 and 1997, and Mesoplodon peruvianus is known from 13 dead specimens from the Pacific, and only 5 probable live sightings that aren't confirmed. Beginning in the late 1960s, we entered the age of conservation. Marine mammals, first whales and then dolphins, played leading roles. Thanks to decades of ineffectively controlled hunting, populations of large whales had declined precipitously, leading to public concern that they might go extinct. Public demonstrations and political pressure was exerted on the International Whaling Commission and the major hunting nations, including a widespread boycott of Japanese products in the early 1970s. In early 1969, another event, the blowout of a drilling platform 6 miles offshore from Santa Barbara, California, spread 200,000 gallons of oil that spewed out for 11 days and polluted 800 square miles, fouled 35 miles of coastline. And news photos of oiled seabirds, dead seals, dolphins whose blowholes were plugged by oil. And these were the first images that we'd seen of stuff like that. Absolutely enraged the public. And there's general agreement that that spill was a major factor powering the first Earth Day in April 1970, and also the founding of the Environmental Protection Agency in December 1970. Another event played an important part too. Fishermen from the United States and elsewhere had developed a new technique for catching tuna in the eastern tropical Pacific by encircling schools of dolphins with huge purse seine nets in order to catch the tuna schools that routinely swam underneath the dolphins. Now, the costs to the dolphins, as you know, were enormous. Nearly 500,000 dolphins of several species died annually during the 1960s, and 6 million or more drowned or died from injuries and stress over the 2 decades that this technique was used. So all of these biological catastrophes motivated the United States to pass the Marine Mammal Protection Act in 1972 and the Endangered Species Act in 1973, and also in 1973 to sign the Convention on Trade in Endangered Species, CITES. Now, those new laws came with costs, and adjustment was a little rocky. For example, antique dealers and museums and native craftsmen were justifiably frustrated during the years that it took to exempt historic specimens from permit requirements. And scientists remain frustrated, probably you do too, by the bureaucratic procedures required for shipping tissues and DNA samples to colleagues in other countries. But far more notable were the benefits. For example, public sentiment and the new laws shaped a new perspective for stranding efforts. By requiring permits for interactions with stranded marine mammals and turtles, at least, they professionalized the field. The training, qualifications, and preparedness of stranding personnel steadily increased, and the specimens they found were more complete because souvenir hunters could no longer carve the teeth out of a stranded sperm whale or walk away with a new dolphin skull for their collections or hack the shell off of a stranded turtle. And furthermore, sympathy for the endangered populations and a desire to help rebuild them stimulated more humane approaches to strandings. Animals had been summarily shot in the past, but now remarkable efforts were frequently made to rescue and rehabilitate the animals where possible, and those experiences are steadily guiding more informed judgments about when rescue should be attempted and when euthanasia is best. Stranding responders had always been able to assign causes of death from evidence of gross trauma, such as ship strike or propeller wounds or severe entanglements in rope. However, new analytical tools that became available over the past 2 decades now enable them to investigate more subtle causes, such as biological toxins, chemical contamination, acoustic trauma, and others. So these tools ushered in a new period, the age of forensic science. The forensic approach utilizes techniques related to crime scene investigation and may indeed be used to bring charges against a person, a company, or an agency for unauthorized taking, for example. However, its main focus is to do a better job in understanding why animals strand. Improved forms, improved standards, and new protocols for necropsies, along with guides illustrating specific kinds of injuries and relating them to particular causes, have heightened the quality of examinations. Important advances have also come from standardization of procedures for taking, storing, and analyzing biological samples. More sensitive analytical techniques have shed new light on the importance of silent killers like saxitoxin, domoic acid, and other biotoxins, as well as bioaccumulation of persistent organic pollutants and heavy metals. And in addition, we shouldn't underestimate the role of cell phones and GPS, as well as GIS mapping, in facilitating rapid response, allowing responders to receive photos of the carcass nearly instantly from anywhere, and to actually be able to find it and map its location with respect to the position of potential stressors. And it's absolutely remarkable that here in the US anyway, all this has happened in less than 40 years. Our modern stranding program traces most of its roots to Jim Mead and Charlie Potter at the Smithsonian Institution. The posters and flyers that they distributed during the 1970s, seeking information about strandings, stirred up lots of interest, many specimens, and led eventually to the founding of the first regional stranding network in the Southeast in 1977. Some of you may also remember the Smithsonian Institution's Center for Short-Lived Phenomena, which was founded in 1968, or the Smithsonian Event Alert Network, which was founded in 1975. While primarily designed to alert scientists to earthquakes, volcanic eruptions, fireballs, and other transient phenomena, Jim and Charlie also used it to solicit and distribute reports of marine mammal strandings and other episodic biological events. So long before fax, email, or Twitter, these special reports were printed on postcards and sent by US mail to participating scientists worldwide. And we thought it was pretty neat to hear what had come ashore in New Zealand or Chile, even if the news took a few weeks to arrive. Now, I should mention that not the least of Jim and Charlie's contributions was brainwashing a small squadron of acolytes to believe that tunneling through mountains of snarch was glorious fun. They accomplished this mainly through deception and distraction, introducing the young enthusiasts to arcane anatomical features, taxonomic speculations, and other lore from their Kabbalah. Escape was apparently impossible once the spell was cast, so that once young pups, such as Bill McClellan, who will be here later, now keep the sacred knowledge and parcel it out to their own acolytes. So you and the stranding responders before you have made important contributions to knowledge as the field evolved through utility, curiosity, conservation, and forensic science. And sometimes the news hasn't been good. For example, strandings revealed the appearance and spread of diseases that appear to be new to marine mammals and sea turtles, such as new cancers of the urogenital tract, oral cavity, skin, or other tissues caused by new forms of herpes or papillomaviruses, probably facilitated by immune depression or malfunction caused by persistent organic pollutants such as PCBs, DDT, and others. Other times, the news has been more encouraging. For example, here in Maine, we've seen increased numbers of harbor seals as the population grew, increased numbers of gray seal pups, and more recently, adults as that population grew, and in winter, steadily increasing numbers of ice seals, particularly harp seals, but also hoods. The ice seals are typically healthy and generally find their way back to sea or are released. So in contrast to our earlier perspective that these animals were lost and doomed, we now suspect that many are just on walkabout and will probably enjoy safe return. Well, thanks in large part to lessons from the whales, dolphins, seals, turtles, birds, manatees, and others that have come ashore, I think we're just beginning to enter a new age, the age of ocean health. Strandings have shown us that something's wrong out there, and not just one thing either. These animals have been sentinels of a nasty mix of stressors, including climate change, contamination by oil and other organic and inorganic chemicals, plastics pollution, sonic pollution, eutrophication, harmful algal blooms, overfishing, and of course, the obstacle course of nets, ropes, and ships that we have placed in the ocean. These and longer-term threats, such as ocean acidification, challenge much of the ocean's life, and they can't be eliminated quickly. However, I see growing evidence that societies here and elsewhere are beginning to understand the huge benefits that a healthy ocean provides, as well as the shattering costs associated with further deterioration. A number of large-scale projects are ongoing now, centered on the concept of restoring ocean health. One that I manage and direct for Conservation International, the National Geographic Society, and the New England Aquarium is creating the Ocean Health Index. Working with collaborators from a number of major laboratories and organizations, we're designing indicators that will track progress toward reversing the unfavorable trends that threaten the ocean's continued ability to provide the ecosystem services that sustain human well-being and indeed all life on Earth. We believe that this project and similar groundswells elsewhere are coalescing into a huge wave for ocean conservation. And we're optimistic enough to hope that it will have the staying power to force long-term improvements despite the many challenges sure to come. What will be the role for stranding programs and networks in the age of ocean health? I don't think you'll be out of work, as there will always be strandings, even if the ocean returns to general health. Tricky sites, storms, magnetic anomalies, and other factors conducive to mass strandings of social odontocetes won't disappear. Despite global warming, cold snaps will probably always disable manatees or marine turtles when they happen at the wrong time. Harmful algal blooms will never completely disappear. And some individuals will always end up on shore at the end of their happy lives in a healthy ocean, and you'll go get them. However, in time, we can look forward to fewer oil spill emergencies as societies make the transition to renewable energy. I think acoustic blast incidents may increase for a while as China ramps up its navy, forcing other navies to respond. But eventually, countries will surely find more productive ways to spend money than running great fleets of warships around the ocean. Entanglements will probably be with us until mariculture or some yet-to-be-invented technology replaces gill nets and rope-tethered traps. But in the meantime, I wonder whether stranding programs
might play a role in the ocean health movement by constructing and maintaining an indicator to track the frequencies of animals affected by the various stressors. With standard methods, pooled and quality controlled data, and constant effort over the long term, I suspect that such an indicator might reveal important trends and add further value to the great work that you and your colleagues are already doing. So if anybody feels motivated to try and create that indicator, I'd like to hear from you. Well, I thank you for the opportunity to talk with you. And Sean, I wish I'd said no, because I wouldn't have had to write all this. But now, having given it, I'm glad that you asked me, and I'm glad that I did. So thanks very much, everybody, and hope the rest of the conference is great.